Activity 1. Aim to assemble a household circuit comprising of 3 bulbs, 3 on-off switches, a fuse, and a power source. Apparatus required: 3 bulbs with holder, 3 on-off switches, a fuse, and an AC source. Theory: the AC voltage is supplied by the electricity board to all consumers at about 220 volts. There are generally two cables carrying the main supply. The the two cables are called the live and the neutral wires. All electrical appliances are connected in parallel with the cable through on or switches, the switch connected to the live wire. To safeguard the the electrical installation, and to protect it from any damage due to short circuit, a safety fuse is inserted in the live wire circuit. Procedure: we do not need to remember the procedure. We need to remember the diagram here, which is the live wire, fuse, and the circuits, and the neutral wire which joins them accordingly. The switch is made according to the live wire, not the neutral wire, and the fuse is connected with the live wire, not the neutral wire. Now, precautions: the safety fuse and switches must be connected to the live wire. Be careful not to touch any live part of the circuit. Use only well insulated wires. Wires connected to the live, neutral, and earth must be according to color code. So, live wire is, let's check color of live wire. Live wire's color is black electrical wires, gray wires. Yeah, here we go. Black is the standard color. Here can yellow. Yeah, brown is the color for live wire. Live red. New colors are this, and neutral is black. These were the old color. Live for red, and neutral for black, and green for earth. Now this is here live red. New convention is these ones: green with yellow strips and green for earth. Now activity 2: to assemble the components of a given electrical circuit. Apparatus required: voltmeter, resistor, a rheostat, a millimeter, battery of 0.60 to 6 volt, and connecting wires. So we need to assemble a electrical circuit similar to these of the household parts, in which we required bulb, 3 switches, and a power source and a fuse. Similarly, here we need like a resistor, a voltmeter, a rheostat, a millimeter, a battery of 0 to 6 volts, and connecting wires. Procedure is similar, we just need to remember this, the diagram, and we need to remember that the voltmeter is connected in parallel with the resistance and rheostat is connected. We need to mainly remember the diagram, and we need to remember that the ammeter is connected here in series with the battery and the resistance. No need to revise the or remember the procedure, you just need to remember the diagram and you would be able to make that. So apparatus required is voltmeter, resistance, a rheostat, a millimeter, and a battery of 0 to 6 volts and connecting wires. Now we need to remember the observations, which is the resistance of the given resistor, which you will have a resistor box in which you need to plug out the key to get the resistance, and it's about 100. You could choose varying from 1 to 5000 according to the resistance box. So 100, and least count for the voltmeter is 0.5 volt, and millimeter is 20 millimeter. So according to your device, these things could vary. Now, what are the precautions that should be taken? First of all, connection should be neat and tight. The millimeter should be connected in series and voltmeter in parallel with the resistance, and should have proper ranges. All precautions regarding polarity should be observed, and zero connection, if any, must be applied. Zero correction, if the accordingly, if it is in negative, you should add that positive, add it in the readings, and if it is in positive direction, we need to minus that, subtract that thing. Zero connection, millimeter, and precautions regarding the polarity, we need to remember these. This is thing that is common in everything, and this could be remembered easily, and you in the exam we need to write at least 3 to 4 precautions. And this is the table that you need to remember: the readings and the millimeter readings, and current passing through that, and difference of I minus I dash. So from here, the current through the resistance is proportional to the potential difference across its end. So accordingly, we can get the answer. um, the easiest way is to perform this activity in according, and you would get the answer. Now, activity 3: to draw the diagram of a given open circuit comprising of at least a battery, resistor, rheostat, key, ammeter, and voltmeter. Make the components Mark the components that are not connected in proper order and correct the circuit and also the circuit diagram. Battery, resistor, rheostat, key, ammeter, and a voltmeter are the apparatus required. Here we would be given the diagram, and in the later images we need to correct the diagram. Usually the teacher gives the voltmeter in series instead of giving it in parallel, and the meter is given in the parallel instead of in the series, and we need to define that. And you would be given the diagram, so you don't need to revise the apparatus required here as well. And the theory is the voltmeter is always connected in parallel with the points across which potential difference is to be measured. The meter is always A meter is always connected in series with the circuit. While connecting a meter and voltmeter, positive should be connected to the positive terminals of the battery. Now these are the diagram. This is the given diagram that you would be given, and most important thing is to be mark this, that the key is open over here, so you don't need to put in the dot over here. Next is, after the procedure, we need to remember the precautions as well over here, and we don't have any precautions, so precautions should be similar to the theory ones, that positive to the positive and a meter connected in series and voltmeter in parallel, so you could write that as a precaution as well over here. Now activity 4: to identify a diode, an LED, a resistor, and a capacitor from mixed collection of such items. uh, First of all, apparatus required is a multimeter, battery, illuminator, reversing key, a diode, an LED, a resistor, and a capacitor. Theory: if you have to identify these items, the working and appearance of each item will have to be considered. Diode: it is two-terminal device. It conducts when forward biased and does not conduct when reverse biased. Now, second is LED. It also has two terminals and conduct when forward biased and does not conduct when in reverse biased. It emits light when conducting, and it is similar to diode in that it also conducts only in one direction and then it emits light. Second is resistor. It has also two terminal device and conducts when in any of the conditions and even when operated with AC voltage. Capacitor is also two terminal device and it does not conduct when DC voltage is applied. However, it does conduct when AC voltage is applied across its terminal. Now for all these diagrams we come across this. This is the carbon resistor, this is the LED, this is the capacitor, this is also the capacitor. Now let me show you the diagram of the other ones. Yeah, diodes, and here's the directions. We need to remember that the resistor conducts in both the directions, while capacitor on current is absorbed in both the direction, but it does conduct in AC rather than in DC. And for diode, it conducts in one direction without emission of light, and LED similarly conducts in one direction but with the emission of light. Now, precautions: as all connections need to be neat and clean, and the current should be observed with the reverse polarity every time, and all precautions regarding the use of a multimeter must be observed. So let me show you the images here as well. Capacitor. Here's the capacitor. It is usually black or blue in color. Yeah, this is one, the capacitor. Second is LED. These are the LED that might be given to you in the school. Second is resistor. Yeah, here's the resistor, and these colors are used in on the basis of correcting the resistance of the band. The color coding is to be done, which is not in the slips right now. And third one is the diode. Diode is here. This is the diode, rectifier diode. You could remember this as well. And the one with the this thing, the silver strip, is the negative one. Silver is positive or negative. So here we go. The one side silver color band is printed, which shows the negative, and the diode which is negative, which is cathode. This is to be remembered. This could be asked in the viva as well. Next is the to observe the refraction and lateral deviation of a beam of light incident obliquely on a glass slab. Apparatus required is the glass slab, drawing board, white paper sheet, office pens, and protractor. The refraction of light is bending of light as it travels from one medium to another. A ray of light, when incident on the face AB of a glass slab at angle incident psi, this ray is refracted along QR, finally emerging along RS. R is the angle of refraction at the first face and the angle of incidence on face DC. Since AB is parallel to DC, the ray emerges parallel to the incident ray but is laterally displaced. The lateral displacement is RT. Let T be the thickness of the slab. So RT by QR is equal to sine I minus R, and R is equal to QR sine I minus R. So here we go. This is the AD, and this. So we have a parallel ray. We have a ray that is obliquely uh, touching on the AB slab with an angle I with the normal, and here it deviates the path and emerges out of the plate on the face DC, which is parallel to AB, and the angle is angle of emergent, and the angle that forms between inside the plane is the angle R, which is the refracted angle. And we could find R. This is the R point. This is QR, which is here, and sin I by sin R, and RT is RT, which is the thickness, which is the deviation that is coming up, is equal to QR into sin I minus sin R, which is the angle deviated actually. Yeah, so this could be also using the Pythagoras theorem. We could find these as well, because this angle and this here, which will give us this, and we could find this easily. It's good. So we need to remember the formula here. R is only, it's only written now, but it's RT is equal to Q or sin I minus sin R. So RT is equal to QR into sin I minus sin R. This is the diagram that you need to draw, and you need to remember this as well. Just remember that this into sin I minus sin R is equal to T thickness. Next is thickness of slab T. We could use different types of things for here. Thickness of slab is equal to 10 centimeter and 15 centimeter, and we could get the lateral displacement RT accordingly, and RT by T would give us the ratios, and it's somewhat uh, we could get that it's somewhat constant, and yeah, here 1.8 and 2.37 is somewhat 2 or near about 2, and we could get that RT is approximately proportional to T, which is lateral displacement. And the main thing that we need to remember here is lateral displacement of a ray of light is proportional to its thickness. Next, we could remember QR is equal to T by cos V. So cos V, here we could get cos V as well. And QR is equal to T by cos V. QR is equal to T by cos V. I don't remember where I have written that. Cos R, actually cos R. According to Pythagoras theorem, we could find that as well. Then we could use that RT is equal to T sine I minus R, T by cos V sine I minus R. Why so? Because we found that RT is equal to QR sine I minus sine R, and QR here we substitute as T by cos V, and we get that cos V 1 by cos V is secant V, and sine I into sine I into 1, I minus R. Then later displacement through the slab depends on angle of incidence, refractive index of material of slab, and thickness of slab. These are the things of theory ones that we need to remember here, that angle of incidence and refractive index of material of glass and thickness of slab mainly comprises of the things on which lateral displacement depends. So angle of incidence, refractive index, and thickness of slab. Next, we have the result that the lateral displacement is actually proportional to the thickness of the glass. And precautions are that the pins that we align over here, you could see this diagram that P1 and P2 should actually have a lot of distance between them to mark these things. And here we go, that the result is here. And the angle of incidence should be between 30 to 60 degree, not below that or above that, and the eyes should be at least 25 centimeter apart to mark the distance actually. Next, we have this activity which is actually very big, and it's very important. These two activities are very important, and this is the index if you want to revise, and if you want to write you could write these as well. Activity 6, A part. So, to study the nature and size of image formed by a convex lens using a candle and a screen. This is actually an activity, and you need optical bench with three uprights, a convex lens. Here we have a convex lens. Later we have a concave lens and mirror as well. I guess the mirror ones are deleted, but we do have one concave as well. Then we need a holder, a burning candle, and a cardboard screen. Now, according to the theory, we have lens formula for this, and we need to remember 1 by focal length is equal to 1 by image distance minus 1 by object distance. So for here we could have that if we put the object distance to infinity, v would come out to be f, because 1 by infinity is equal to 0. And if we put u to be minus 2f, then we could get v as 2f. And if the object is placed between the focus and the optical center, the image is virtual and will not be formed on a screen. So we need to either put it away from the focal length, either ways. Thus we see that as the position of object varies, the position and the size and nature of the image also varies. So first we need to set the upright and all, and we need to get the diagrams here. This would actually be an like we're placing the thing here, so we're getting it here. If we place it upright, we could get this, like I guess you are understanding, you all are understanding how we get the image. And we need to remember the diagram over here as well. Now result is, as the position of the light candle is changed, the position of the screen has to be changed to get a sharp image according to the theoretical predictions, and the size of the image is observed to be in accordance with the above table. And we need to remember this. I guess we have done this in previous classes for about ninth and 10th as well. And over here, if we place the object at infinity, we get the image at infinity. If we place the object at 2f dash, we get the image between f and 2f. And we place the image at 2f, we get the image of 2f. Between f dash and 2f dash, we get the image beyond 2f. And if we place the image at f, we get the real image at infinity. For all the above 5 points, we have the image which is real, and which real image, and actually it is inverted. And accordingly, if we place the object at infinity, it would be small size, the point size, or highly diminished. And beyond 2f dash is diminished, not highly diminished. And at 2f dash, we get the image of 2f, and it's a real image of the same size. And if we place the object between f dash and 2f dash, we get the image beyond 2f, and we have a real and enlarged image. And if we place the object at f dash and at infinity, we have a real and highly enlarged image. And if we place the object between f dash and optical focus, optical O point, or the center on the same side, we get the image on the same side, which is on the left. If we take over here, we see over here, we place the image over here in between here, if you could see. So we get the image on this side, which is the left side, and we get the image highly enlarged and virtual. Now accordingly, we have taken the things, we have fixed the position of the convex lens, and we need at least uh, three readings for this. And these are the answers. If we take the candle frame over 5 centimeter, 8 centimeter, 12 centimeter, we need to place the screen accordingly, and we get the answers of size of images as well accordingly. uh, you all might remember the formula as well, we could use that. The precautions are the position of lens should be fixed, and we need to mark the f and 2f dash, 2f point positions on both the sides, so that we can have the upright carrying the candle in different desired positions. All uprights must be vertical. um, Vertical, yeah, uprights, the things on which we put in the needle and the candle, everything. And we need to adjust the position of screen so as to get a very sharp image on the screen. Next is the result here as well. Then the second most important activity is activity 6b part 2. So we need to study the same thing using a concave mirror on a screen by using a candle and a screen. So first of all, we need an optical bench with three uprights, a concave mirror, and a holder, and a mirror holder, and a burning candle, and a cardboard screen. So here we use the mirror formula. Over there in the previous activity, we used the lens maker formula. Here we're using the mirror formula, right? So accordingly, we use 1 by v, which is the 1 by image distance plus 1 by object distance is equal to 1 by focal length. And if we place the image at infinity, we get focal length to be sorry, not the focal length, we get image distance to be f, actually f, not minus f, it should be f. And if we place the image at minus 2f, we get the image at minus 2f as well. Next we have hence object is moved from infinity towards the concave mirror. Image is moved from focus towards infinity, and the position and the size of the image for different positions of the object it changes. So procedure is similar, we could use that as well. So we need to remember this diagram over here with in the lens one, we placed the candle over here and we got the images over here. If you remember this image, Yeah, right. So we place it between 2f and f. We got the image beyond 2f, and similarly we need to remember this as well. And if we're placing the image over here, at the I could say center of curvature, beyond center of curvature, we get the image between center of curvature and focal length focus, and we get the image which is about diminished, and it's a real image actually, and we get image which is inverted. We need to keep in mind what are the precautions. Keeping the position of the mixed fixed mark F and C on the meter scale. We need to fix those positions, and we need to place the object needle in any of those positions, and all the uprights may be vertical. I I usually prefer them to be vertical, and always adjust the positions of the screen to get a sharp image of the object. Now, observation table, again, you need just three observations. You could remember these, or you could find out these as well in the practical. Then here we go. We are completed all these activities over here, and I guess you find it easy. Thank you. Bye bye. And soon we're gonna start the physical practical as well. It's a little lengthy, but it's easy. And for the project file, it will be way easier because I have the previous year's project files here, and we could use that for our experimenting, for the reading, and we could conduct a viva as well. Thank you.